Hello, everybody, and welcome to the second part of our lecture, Modified Chemically Soil Model. In the previous part of this lecture, we have covered the history of the Modified Chemically model, the main parameters that are used in this model, the basic assumptions, and we discussed in detail the critical state theory. In this part of our lecture, we will list the main applications of this model, and then we'll go to the limitations of this model. Finally, we'll go to a brief conclusion. And just I want to remind you that the references that are used in this lecture are listed at the end of this presentation. PDF slides will be attached below the video in the description. Now, let's go to the applications of this model, where we can apply the modified chemically model. It can be applied in any branch in geotechnical engineering. Starting from the foundation design, this model can be applied to estimate the settlements and the bearing capacity of the shallow foundations. It can also be used in evaluating the stability of the natural and man-made slabs by providing insights about the shear strengths and deformation characteristics of the clay. It can also be used to analyze the stress-strain response of earth-retaining structures such as the retaining wall. It can be used to simulate the consolidation behavior and predict the potential failure of embankments and dams. It is also applicable in the design and analysis of tunnels and deep excavations. Other applications of this model includes the soil structure interaction, the consolidation analysis, the seismic analysis, the analysis of the foundation of the offshore structures. I mean the structures that are built in water, mainly such as petroleum structures, for example. And finally, it can be applied to analyze the mechanical behavior of clay liners in landfills. However, as any soil model, this model has many limitations. It's very important for geotechnical engineers working in the design, geotechnical analysis and design to know the limitations of the model they are working with or they are using in their analysis in order to avoid any overestimations or underestimations and any unreal results obtained by this model due to its limitations. So, what are the main limitations of this model? First, it overestimates the stresses in the dry site. What do we mean by dry site in soil mechanics? It refers to the condition where the soil has a lower water content. So the water content low in the soil. The soil is denser and the void ratios are small. So this is one limitation of this model. The second limitation is that this model assumes an associated flow rule, and I explained in brief what is associated flow rule in part one. I will be discussing in an independent lecture about the associated flow rule, about the soil hardening and the soil softening in details later on. Now, in this case, the model will be unable to predict the important feature of the behavior that's commonly observed in undrained tests for loose sand and normally consolidated undisturbed clays. Also, it's important to note that the critical state theory has been less successful for modeling the granular materials because it's unable to predict the softening and the latency of the sand of the dense sands. Also, the materials that are modeled by critical state models, they are limited to saturated clays and silts. That's why we call it modified CAM clay model. It is mainly applicable in saturated clays. So if you are working with or dealing with other type of soil, it is recommended not to use this model in your analysis. The other limitations includes it is elastoplastic nature, which means this model is not able to analyze complex time-dependent behaviors, for example, the creep and the rate-dependent effects. The model also goes for a simplification of the real soil behavior, especially under extreme conditions. The isotropic hardening, also I explained in details what do I mean by isotropic or what is meant by isotropic in part 1 of this lecture. That means the compression and the expansion of the soil is symmetrical. It is the same in all directions inside the medium. Okay, also this model is able to simulate the behavior of different over-consolidation ratios. It's not able to capture the evolution of the over-consolidation ratio during shearing. Maybe it's not important in all cases to do this prediction. However, it is maybe essential in other applications, and that's why we should consider this point. The last limitations are the stress path dependency. Because of some types of clays, the response can be stress path dependent. And in this case, it will be not able to be captured effectively using the modified CAM clay model. The strain rate effects, you have to know that this model is mainly used in situations the strain rate is not very high or not very low. That means it's not used in extreme strains. So in case you are working or dealing with some conditions that you know there is a very rapid or very slow strain rates, it is recommended not to use this model because it will be it's not representative in this case. As I said before, the high strain behavior cannot be described in details using this model. And finally, the cyclic loading, mainly in the case of earthquakes, for example, this model is not designed to capture such scenarios of the cyclic loading. So, as I said before, understanding the limitations of any soil model is very important to avoid these limitations, to know how to deal with these limitations, because as much as you make your soil model very representative to the real case, then you will go to a safe and effective geotechnical design. Otherwise, you will be doing analysis which is not representative, and then you will go to structures which are not safe. Mainly, they are maybe over-designed. So many problems can occur when you are designing your geotechnical structures. Finally, how can we describe this model? This model is accurate and suitable to analyze the deformation behavior than the failure behavior. It is simple, however, it is effective for mainly clays. It can capture the complex behavior of clays. However, you have to remember, as such any soil model, no soil model can represent 100% the real behavior of soils. However, we have to try as much as possible to make our model reflecting the real behavior in reality of the soil. That's why whenever you are using any soil model, it is important to combine the results from your model with laboratory and field tests as much as required and it's possible. Finally, regardless of its limitations, the modified Kamek-Clay model. It is a powerful tool in many geotechnical engineering applications, mainly to used in saturated clays and silts. For you as a geotechnical engineer, it is very important before deciding which model to select for your case is to understand the case, understand the requirements, the type of the soil, the conditions, the data you have, and then you have to associate the model that is very well representative for your case. Thank you very much. I hope this information is useful for you. And as I said before, the references that are used in my presentation are listed in the last slide of this lecture. Thank you very much.